We're starting off mechanics with a really good topic, which is SUVAT, the constant acceleration equations. Now, shockingly, these can only be used when acceleration is constant. So let's go through these quickly. There are 5 equations that you need to know, and you need to remember these. But you're going to be using these so frequently that you will just remember them naturally. These always come up in the mechanics section of the paper, but they also come up in a few different topics sometimes. So they can also come up in other topics. I'm not going to mention them now just because I don't want to scare you, but they do come up a lot. So what I would recommend you do is on a little post-it note, on a little bit of paper, write out this top thing here, and then just have it in front of you whenever you practice. And that way, over time, you'll start looking at it less and less and less, and you start remembering it. But you have these equations here. I won't read out all of them just yet, but here are the different letters. So we have S, which is the displacement. U and V are the initial and final velocities respectively. A is acceleration and T is time. Now you might notice these are all vectors besides time, which is really, really important. Okay? Because the direction matters in SUVAT. Now the reason why I want to emphasize this is a lot of you guys from GCSE Maths still don't draw diagrams to illustrate what's happening in the scenario. With mechanics, there's no excuse. You have to draw a diagram. You will make mistakes. You won't know how to do it if you don't draw diagrams. Now, yes, in a few questions you might happen to get the right answer, but not in all of them. I guarantee it. So that's one thing, is you have to draw diagrams, because I have to know, because these are vectors, they have direction, which means in one direction they'll be positive, in another direction they'll be negative. So I need to know which one's positive and negative. 2, and this is really important, there are multiple ways to solve every single mechanics question. So the way I do it is going to be the way that I believe is the easiest. But if you find another way but still get to my answer every single time, then you're completely fine, you're correct. But there are multiple methods. I will show you one method and I will describe another method. But you can completely ignore that if you're fine with my method. So these are the equations we need to use, and these are what these things mean. And let's just get, the best way to learn SUVAT in my opinion is just to jump straight in. So let's look at the first question. So this is a very stereotypical question that you might get asked, is you have a ball is projected vertically upwards with a speed of 20 meters per second from a point h meters above the ground. The ball hits the ground 5 seconds later, and we need to find 2 things about it. Now, here's what I'm going to do is I'm going to draw out this scenario. Now, what they're saying is we have this ledge and we have the floor here, and this ledge is h meters high, correct? They then throw a ball up into the air and it comes down and hits the ground. Okay, that's essentially what they're saying. Now I like to label up a few things. So for example, the first thing is that they project the ball upwards, so that's 20 meters per second. Yeah. It hits the ground 5 seconds later, we can't label that because it's time. H meters above the ground, we have that. But we also have acceleration, which is acting downwards. And that is the acceleration due to gravity. So I'm going to call that G. Now, what do you take G as? That's a really good question. Normally, they will tell you in your exam paper what to take it as. Sometimes it's 10, sometimes it's 9.8, sometimes it's 9.81. For the purposes of everything we're going to do, I'm going to take 9.81 meters per second squared, okay? The reason for this is they very rarely use 10 meters per second squared, so I've disregarded that. And the difference in answers between 9.8 and 9.81 is minuscule. So if you use 9.8 instead of 9.81, you're going to get a very similar answer anyway. But let's keep going. Hopefully that all makes sense in terms of the diagram. Now, here's what I always do, is I write out the letters. S equals, U equals, B equals, A equals, T equals. Okay? And I write it for this scenario. So what is the displacement? What is the initial velocity, final acceleration time? And if you notice, it's going to ask us for 2 of these things, which is fine. But this is where I need to actually think. Which direction am I going to take as positive? Well, for me personally, I always take the direction of gravity to be positive. Now, you might be thinking that seems a bit strange, but I will give you the reasoning why. When we move on in mechanics, we're going to come across a lot of different scenarios, a lot of different vectors and things like that. And generally speaking, acceleration is the one people forget is negative sometimes. So in this case, you could take upwards as positive and you'll get the right answer. You could also take downwards as positive and also get the right answer. Why? Well, the reason being is if I take upwards as positive, 20 meters per second is positive, gravity is negative. If I take downwards as positive, gravity is positive, but the 20 meters per second is negative. So it automatically fixes itself. So just for this, I'm going to take downwards as positive, even if this doesn't necessarily make much sense. Again, I will show this to you. If you could use it the other way if you wanted to. So first of all, what is S? What is the displacement? Now here's where people get confused. Displacement is the actual distance from the starting point that you've travelled. So let's say, for example, this is my home and this is school. Yeah, I'm going to say that distance is 100 meters. Now if I walk to school and then back home, I've covered a distance of 200 meters, right? That makes sense. 100 meters there, 100 meters back. But what's my displacement? What's my distance from my starting point? 0. I haven't moved from my starting point. I'm back where I started. That is the thing about vectors. They have direction. So going 100 meters that way and 100 meters back means I have no displacement. I haven't moved overall. Another way to illustrate this, which I think can be quite useful, is like this. Again, let's say I start here at point A and I go to point B. And I take this really weird windy route around. Okay. My distance travelled is going to be all of this length added together, whereas my displacement is a direct line from A to B, as the crow flies, so to speak. So in this case, what is the displacement? Well, okay, it goes all the way up some distance. I don't know what that distance is. And it drops down. If you notice, that means it goes down h meters. So the displacement is h. Now, is this positive or negative h? It's positive because I'm taking downwards as positive. This thing has travelled h meters downwards. Therefore, it's positive h. If I took this upwards as positive, I would make it negative h and get the same answer. Cool. So what's u? Well, it's going up. If you notice, it's going opposite to the direction that I've taken as positive. So it's going to be negative 20. Because it's going opposite to the direction that I've chosen as positive. And that's why choosing a direction is so important. Okay? Because it's not really intuitive that h is positive and 20 is negative. Or vice versa. Now what's V? Well, V I don't know, and if you notice, that's actually part B over here. So I don't need to know that yet. What's A? Well, again, I'm going to take it as 9.81. And what's T? Well, it says 5 seconds later. So T is going to be 5. Cool. So now I have my variables. I want an equation that links S, U, A, and T together, because those are the variables I care about. I don't care about V because I don't know it and I don't want to work it out just yet. Now, which one of these is it? So S, U, A, and T. Well, which one has S, U, A, and T in it? Well, this has V, this has V, this has V. Boom. S, U, A, and T, no other letters. That's how kind of quick you can do it. So just before we move on, I would like to point out why I do it this way. If you write this out, in the exact same way every time, your brain will get used to this layout. Now, the second I wrote this out, it popped into my head. I didn't even think about it, that I'm going to be using S equals UT plus half AT squared. I didn't even need to think about it. Why? Because I just knew it. My brain has seen this layout a billion times over and over. Okay? Because there's only a certain combination that they can give you. Right? One of these is going to be missing, the others will be present. Or two of these will be missing, the others will be present. There's not that many combinations. So as you practice, your brain will recognize instantly all the combinations. And so you'll just instantly think about what equation you need to use. At the beginning, it's going to be very hard. Okay? But again, that's why you have them written down. You say, okay, S, U, A, and T. Well, it can't be this one because it has V. It can't be this one because it has V. It can't be this one because it has V. This one, it only has the letters I want. So that's the one I have to use. Hopefully that makes sense. And now if you notice, it's just h equals minus 20. Again, I like to put everything in brackets just to make sure I don't make a mistake. Plus a half, 9.81 t squared. Now if you notice, and I'm going to keep interrupting, but I promise it's going to get faster and faster as we go on. This here, can you see it looks like the negative x squared graph? You see that? That is why this equation works, because if you look, it is a quadratic, isn't it? So, we use a quadratic equation because this looks like a quadratic. That can also provide a hint, okay? Which is also why this works, because h is all the way down here, it's going to track this automatically. So now all we need to do is pull up our calculators and work out what the answer is. So let's make this slightly bigger so you can all see it. So minus 20, close bracket, open bracket 5, plus a half, I'm just going to call it 0.5 just because I'm a bit lazy, 9.81 and 5. And that gives me negative 75 point blah blah blah. So negative. Now that is the displacement that the, what is it, a ball? Yeah, the ball is projected. So the actual value of h, so the value of h is just 75.5 meters to 3SF. Right, because when you say how high is something, you wouldn't say negative 75 meters, you'd just say 75 meters. Now, does that matter? No. In an exam, you'd get the same marks if you did it either way. I'm just doing this because it would make more sense. I'm assuming some of you out there, again with A levels, it's all about understanding the maths. So if I said, oh, it's negative 75 meters high, I guarantee you some of you are going to be like, well, that doesn't make any sense. And you'd be right. That's why I've rewritten it as this. This here is my displacement. This is actually how high up the ball was. Then for part B, if you notice, it says, find the speed of the ball as it hits the ground. Now, the good thing about this is we actually have, so if we fill in, again, our values, so we have minus 75.5 for the thing, u is equal to minus 20. V is a question mark, A is 9.81, T is 5. So, if you notice with this, all of these values are actually known, aren't they? So technically speaking, we can use any of these, any equation, and we'll get the right answer. So you could use v squared equals u squared plus 2as, you could use s is vt plus half at squared. I mean, you couldn't use these ones, but all you have to do here is think about what's the easiest. Well, in my opinion, the easiest is definitely one of these two equations. And it's up to you what you want to use. I'm going to probably choose the first one, because it's a bit smaller. U plus at. So u is negative 20 plus a, which is 9.81, 5. Let's have a look at this. I just realized I made a mistake in the answer. If you notice, I actually didn't press squared. So let's square that. 22.625. Good thing I spotted that. Okay. I'm assuming some of you spotted that and were wondering. 22.625. So that would then be 22.6 meters. Okay. Apologies for that. And I was actually going to make a point about this. If you notice, downwards is positive, right? So my h should have been positive anyway, because it's pointing in the same direction as the plus arrow. This answer should be positive as well, because my velocity should be going downwards now, because it's speeding up going downwards. So this answer should be positive, and if you look at the numbers, it is going to be. So negative 20, negative 20 plus 9.81 multiplied by 5. We get a positive number because, again, the arrow is pointing downwards. So if you did this question where the arrow is pointing upwards, you would get the same number, but negative. So the value would be the same, but it would be a negative value as opposed to a positive one. So the magnitude is the same. And that would just be because your arrow is pointing upwards. You took upwards as positive. In my case, I took downwards as positive, which means I get a positive value because it's going to be speeding up going downwards. Okay, hopefully that makes sense. If you look at the number of marks and actually look at the maths we did, we've done 3 lines of maths here, we've done 3 lines of maths here, and we get 6 marks. That isn't bad, and this is what I love about mechanics. I truly do love this. Once you get good at this, you'll be able to do this question in about 2 minutes and get 6 marks. And there are some questions that come up later that are 8-9 marks long that I've managed to do in 2 lines of working out. So it's so quick and easy. But so why do they give you this many marks? Because you need, to get this answer right, most people get it wrong. To get it right, you have to draw a diagram and take a direction as positive. And if you use my tip of writing stuff out like this, it becomes easier. So the reason why it's worth so many marks is because mechanics is always for 90% of people, the worst subject. Because it takes a lot more thinking, a lot more logical thinking, a lot more problem solving. I'm going to try and remove that for you by getting you to draw out the diagrams, by getting you to write out the variables, and that just takes away the decisions for you. It gives you that structure that you can always apply. So, in short, the reason why they give you so many marks is because they expect you to draw a diagram and write out the variables, because a lot of people don't do it and they get the answer wrong. So draw a diagram, didn't take me very long, write out your variables and you can get full marks. But let's move on to the next question. Here's another type of question that a lot of students find tricky. And they find it tricky because, once again, they don't necessarily draw diagrams. So if here a car passes point A with a speed of 20 kilometers an hour, accelerates at a constant rate, good, because that means we can use SUVAT. You should always be looking out for this sentence here, or something that implies the acceleration is constant. The reason for this is you can't use SUVAT if it's not constant. And we do cover variable acceleration. So there'll be 2 options, variable or constant. You have to look out for it. 10 seconds later, it passes a point B with speed 70 kilometers an hour. Find the acceleration in meters per second. Now, this is going to be a bit more annoying. You have to convert the units. I would convert them from the beginning. So I'm going to now convert them, and I'm going to show you how to do that. Okay. So we have 20, and I'm going to write it as kilometers over hours. Okay? There is a reason for this. To go from kilometers to meters, you times by 1,000. And to go from meters to hours to seconds, you times by 60 to get minutes, and you times by another 60 to get seconds. Is that fair? So in other words, we're going to times the top number by 1,000 and times the bottom number by 60 times 60, which is 3,600. Now the reason why I wrote it as a fraction is, look, the top number we're going to be timesing by. The bottom number we're actually going to be dividing by. Why? Because it's on the bottom, it's a denominator. If I'm making the denominator of a fraction bigger, the overall number gets smaller. So that's one way of thinking about it. The other way of thinking about it is logically. So if it's 20 kilometers, it makes sense that it would then be 20,000 meters. It makes sense that it gets bigger, right? I will cover more meters than kilometers because kilometers are bigger than meters. So now if I do this first step, it's going to be 20,000 meters per hour. Yeah, that makes sense, right? If I've covered 20 kilometers, it makes sense that I've covered more meters because a meter is a smaller unit, and I would cover even more centimeters or more millimeters. Now think about this. Imagine you're doing this journey yourself. In an hour, you can travel further than in a second. So the numbers should get smaller when I go to seconds, right? Because I travel less distance in a second than an hour. That's obvious. So that's why we would then divide by 3,600 to get meters per second. Now, once I've shown you this conversion once, you can just try and memorize it. They will only really give you kilometers per hour into meters per second. They won't give you anything else. So you can memorize it if you'd like. They wouldn't give you like meters per hour or meters per minute or something weird like that. So if you want, you can just memorize it. But hopefully this logic makes sense. So 20 kilometers per hour is equal to 20,000 divided by 3,600. Now this is going to be a bit of a weird number, So what we could do is leave it as 5.56 just for the purposes of our question. Or you could leave it as a fraction. I'm not too fussed. And what about 70 kilometers per hour? Well, we follow the same process, right? We first times it by 1,000. So 70 times 1,000 is obviously 70, 1, 2, 3, 1,000. And we still divide it by 3,600 to go from hours to seconds. And that gives me 19.4, let's call it. I hope that makes sense. Now let's draw the situation out. So we have a point A here, and we have a point B here. The speed at this point here is 5.56 meters per second. And the speed at this point here is 19.4. Now the acceleration is a constant, and it's going to be going to the right because it speeds up as it goes to the right. The time is also 10 seconds. And we don't know the distance and we don't know the acceleration, but we actually have everything we need to know. How do I know this? Well, that's a good question. Well, let's write out the SUVAT formula. We have S is equal to, don't know and I don't actually care. U is equal to 5.56. V is equal to 19.4. A is equal to, again, don't know, but the first question here is what I want, so I'm going to leave it as the letter, and T is equal to 10. So U, V, A, and T. Let's go back to the beginning. The first equation. That's what we're going to use. V equals U plus AT. For part A, let's use V equals U plus AT. Now, the one thing I should do before we continue, and it might not make sense, it might not be immediately obvious why we need to do this, but it's good practice. I'm going to take to the right as positive. Now, you might think, well, obviously, everything's positive anyway. I know. But there are questions like this where the acceleration could be negative. It could slow down. And if you don't take a direction as positive, you'll get a weird answer that doesn't make sense. It'll be the wrong answer. So get in the habit of always choosing a direction. Because in 90% of mechanics questions, it's going to make a difference. So, right is positive. Yes, everything's positive in this case. Cool. Because again, the velocity here is this way, U is this way, acceleration is that way anyway. So let's sub in the values. We get 19.4 equals 5.56 plus A times 10. So I'm just going to call that 10A if that's okay. Because again, T is 10, A is A. So we've got that. That's minus 5.56 from both sides. I'm a little bit lazy, so I like to just leave it like this, equals 10A, and then divide both sides by 10. And I just do it all in one go on the calculator. You might also want to rearrange it algebraically instead, which is actually my preferred method. My preferred method is actually to rearrange for A and then sub it in, but I know a lot of students don't like that, which is why I do it this way. But it's all good to me. So let's keep going. 1.384, let's call it 1.38 meters per second squared. I am now aware, and this is quite interesting because this is an exam question, that this is meters per second. It should be meters per second squared. Not exactly sure how the exam board messed that up, but is what it is. And lastly, the distance AB. Well, if you notice, we have everything except S. So we can use any equation we like. So pick the one that's easiest. So what's the easiest one? Well, it's the one that has S on the left-hand side. So any of these will do. I'm going to use this one. Completely up to you. If you want, at home now, try using one of these other ones and show yourself that you get the same answer. Because some people do say, well, how comes there's multiple equations that give me the same answer? That doesn't make sense. So the best thing to do is just prove it to yourself. So I'll use this one, you use one of the other ones, and then you'll see that it is actually identical. It doesn't make a difference. 5.56 plus 19.4 over 2 and times by 10. Sorry for that annoying pop-up. Anyways, let's go through it. So let's do brackets and enter it exactly as I have as well. So a lot of A-level students, like, they start to get a bit arrogant and they don't use brackets and things like that. It's vital, man. Like, order of operations. 124.8 meters seems reasonable. And that's also another thing you should be asking yourself is, are your answers reasonable? If you say, I'm not really sure if it is, that's totally fine. But have a think. You know, just use that logical brain of yours. In this case, 100 meters isn't ridiculous to accelerate from 20 kilometers per hour to 70 kilometers per hour, right? That seems in the realm of possibility. If you've got something like 10 meters or 1,000 meters, then you might want to worry. I love this type of question because it's 6 marks. That is so free. It's so free, it's unbelievable. This is something called a free fall question. And the reason for this is, if you notice, they give us like no information. A stone is dropped 120 meters high, that's it. I know, right? It doesn't seem like much, but you have everything you need. Everything you need. And let me show you how you have everything you need. So first of all, we have a stone, let's draw that. And it drops down, this is our displacement, 120 meters. So what else do we know? Well, if it's dropped, it's acting under gravity. So we know that we have gravity. What else do we know? Well, we know that the starting velocity is 0 because they just let go of the rock. It still has a velocity. The velocity is just 0. V we don't know, granted. And T we also don't know. But that is actually everything we need. In SUVAT, if you have 3 variables, you can work out the other 2. Any 3 variables and you can work out the other 2. In this case, I have S, U, and A. If you have 3 variables, you can work out every other variable. So that's all you need. Look for 3. Again, what direction should I take as positive? It's always going to be, well, I like to take the direction of acceleration, just to keep it nice and consistent. So again, S is 120. U is 0. And I'm going to show you why this is so good. A is 9.81. T is, don't know, but it's what I want. The reason for this is S, U, A, and T is you're going to use this formula here. Can you see how that's the only one that works, right? So take a second, I'll give you 3 seconds. It's the only one that works, right? Now, why am I getting so excited? Why is it so good? Well, if I write this out, U is 0. Gone. You lose a whole term. Now, I want time. So again, you could sub it in first. But look what happens if you just rearrange it, right? You could times both sides by 2. So you get 2s equals at squared. Divide both sides by a. 2s over a equals t squared. And that means t is equal to the square root of 2s over a. This formula here, anytime you see a free fall question, you're going to use this formula here. And that's why I love it. Because you're going to literally use this every time you do free fall. That's why I'm saying it's so free. Because there's no thought. You always use this equation. You know what I mean? 6 marks, done. We're going to get 3 marks now, and we're going to get the next 3 marks again really quickly. It's so nice because the first part, you always use this equation. The second part, you always use this other equation I'm going to show you in a second. But you always use it. So, t is equal to the square root of 2 times 120 over 9.81. That's why I love these questions. So let's pull up our calculator once more. Square root and 2 times 120 over 9.81. That's good. 4.95, let's call it. Now I know what you're probably saying. Well, how do I know if it's positive or negative? Brilliant question. It's time. Time can never be negative. Okay. Although we are going to get negative time, but it's never the answer to the question. What that would mean is it's before the actual thing takes place, so it doesn't make sense. So it doesn't exist. Cool. For part B, we can use any equation we like because we only have one unknown. But the best one is, and again, I want you to take a second. I hope you wrote down the formulas and you're following along. I'm going to give you 5 seconds to think about which one you would use. Okay? Just 5 seconds, have a look through which one you're going to use. Or pause the video ideally. But you're going to be using v equals u plus at. And why is that? Well, once again, u is 0. It's just v equals at. So easy. Nice and quick. Not too bad. it's 9.81 times 4.95. How nice is that? Really good. So in every single free-fall question, you'll use this equation and you'll use this equation. It's really, I don't know. I really like them. But a lot of students, what they do, and this is very, very common, is you guys are a bit lazy. Now, I think it helps that I'm a teacher because I'm so paranoid about getting something wrong that I write things in very, very careful steps because, you know, I don't want to be made fun of by the head teacher or like the class, right? But for you guys, you don't have that fear because you're just writing it for yourself. So what they do, and this happens every time, is they look at this first sentence and they say, so it's not possible. How do I, there's not enough variables. Not enough variables. And I say, how do you know there's not enough variables? They say, but they've only given me distance, displacement. And I'll say, have you drawn the diagram? They say, no. I said, draw the diagram. They said, but there's not enough. I say, draw the diagram. They draw it. And I say, see, it's only 120 meters. I say, okay, what's the initial velocity? They don't say. They kind of do. 0? Yeah, there you go. What's the acceleration? Gravity. There you go. 3 variables. Draw the diagram. Every question, I promise you, has to have enough information for you to do it. Logically speaking, it has to. So, what your role is, what your job is to find out what the variables are. And that's your role. Just draw the diagram. So we have another startup question. It looks very similar to the one we just did, so I'm hoping it's not going to be too overwhelming for you. So we have a particle moving along a straight line from point X to Y, constant acceleration again, so SUVAT. Distance is 120 meters and it takes 8 seconds. And also tells us the speed of the particle at Y is double that at X. So again, it might be overwhelming at the beginning, so let's start drawing this out. So we have a point X here and a point Y all the way over here. And the distance between these two, ignore the wobbly line, is 120 meters and it takes 8 seconds to travel. It's a constant acceleration, so again it's accelerating to the left, to the right. So we're going to definitely be taking this way as positive. And it also gives us that the speed here is going to be u, that's the starting speed, and at the end it's going to be 2u, because it's twice the speed. Find the speed of the particle at x. So let's quickly write out what we know for sure. So we have s is equal to 120, we know that. We have u is equal to u, and v is equal to 2u. Then we have a is equal to don't know, and we don't actually care, and t is equal to 8. So if we want to find the starting velocity, or even the finishing, we have s, u, v, and t. And the reason why I'm saying we know what u and v are is because although we don't actually know their values, we know how big they are with respect to each other. If you notice, if I use both of these, I only have one unknown. Okay? So this counts as me knowing it as if it was a number. So S, U, V, and T. So if we go all the way up to the top, S, U, V, and T, you can have this one here. And that's actually the only one. So S, U, V, and T. This one, S equals U plus V over 2T. So let's go all the way back down again. U plus V over 2T. Now let's sub in those values. So we have 120 meters on the left-hand side. And that equals u, which is u, and then v, which is 2u over 2 times 8. So let's simplify this algebra. Again, I want to take it nice and slow, but you can do this algebra as quick as you like. U plus 2u is 3u over 2 is going to be 3u over 2 times 8. If we want to now, we can actually times these two, so that would be 24 over 2, so that would be 12. So 120 equals 3 times 8, which is 24, then divide by 2 is going to be 12. U, which means u is equal to 10 meters per second. That's it. Okay, so even though we don't know the value, we know what it is in relation to each other. And that's a really quite an important thing, is if you think about numbers, they only give us an idea of what they are in relation to other numbers. Right, the number 1 is 1 more than 0. The number 2 is 2 more than 0. So realistically speaking, all numbers are basically algebra. It just tells us how they're in relation to the number 0, which is why 0 is the most important number in maths. Because without 0, 1 has no meaning, 2 has no meaning, and so on, going all the way up to positive and negative infinity. So because we have this relationship, it counts as us knowing it. Now that did get a bit technical in terms of the maths, but all you need to know is if you have two variables and they're unknown, but it's only one unknown in between them, then it's totally fine. And for part B, the acceleration, I'm actually going to write part B next to it instead, just to keep it nice and contained. We can use whatever we like. So it might be a good idea to essentially use the most basic SUVAT formula. So this actually comes from V is equal to, actually I'll write it over here, V is equal to U plus AT. But if you know, acceleration is just the change in velocity with respect to time. So it's actually the same thing in that regard. So either way you want to write it or rearrange it, we have here A is equal to, V is equal to twice what U is, so that's going to be 20 minus 10 over 8. That equals 10 over 8, which 5 over 4, let's see, 1.25. Like so. Hopefully that makes a bit more sense. You may have noticed that we're barely halfway through the questions. In fact, I'm pretty sure we're not halfway through the questions yet. But that's because there's so many different questions to do in this, and it's all about practice. This is by no means an exhaustive list. Don't just practice this set of questions over and over and over again. You want to practice as many as you can. The good thing about this is you could go back to past papers from 1995 if you wanted to. And there are papers from 1996. Okay? Because this maths hasn't changed and the start of question hasn't. So you can go to the old spec and do something called M1 papers. M1 papers. Which is, it's old spec, but it had SUVAT in it and there's no difference. So you can literally find basically an unlimited number of these questions. Hundreds and hundreds. And if you want to buy the textbook, that has more in there as well. But of course, if you can get it for free, why buy the textbook, right? Okay, so again, we have a car passes point A, speed of 5, constant acceleration, 8 seconds, pass with B. I want you guys to have a go at this, okay? At minimum, you should be able to do part A and B. Part C may be a bit trickier, but I want you to pause the video and have a go. Let's get some active learning done. Okay, I'm going to assume that you did actually pause the video and went. If you didn't, shame on you. And let's just draw the diagram once again. We have a point A and we have a point B. It's a constant acceleration, so let's fill that in right now. Like so. And 8 seconds later, so we have here a speed, so U is equal to 5 meters per second. And that's going to the right. And we also have V is equal to 20 going to the right. And overall it takes 8 seconds. We don't know what the distance is, which is what part B is asking us, and we don't know what the acceleration is. Once again, let's just write out what we know. So we have S is equal to don't know, and I don't care just yet. U is equal to 5. V is equal to 20. A is equal to don't know. And T is equal to... In fact, instead of don't know, what I'm actually going to write it as the letter A, because it's actually what I'm looking for in the first part, is equal to 8 seconds. So if I look at part A, whoops, I don't know what happened there. Part A, one equation that pops into mind immediately is the one we used before. So you can either call it V equals U plus AT, or you can simply say it's the change in velocity over time. Whichever one you like to do, this is just a rearrangement of this formula, all the other way around. So if we sub all those numbers in, we get a nice and easy calculation. 20 minus 5 over 8. So that's 15 over 8, which would be 1.75. Actually, no, it wouldn't. Let's just type it on a calculator. 15 divided by 8 equals 1.875, okay. Let's call it 1.88 for that 3 significant figures. Generally speaking, 3 sig fig is very, very safe. And look at that, 3 marks. Come on, are you not seeing that this is such 3 marks? Draw a diagram and you're done. And I'm willing to bet the rest of these marks are going to be pretty easy too. 10-mark question in total. Beautiful. Now the reason why I say this is easy is because now distance, well, we have everything except distance. We can use whatever equation we want to use. Any one that has S in it anyway. So you can use half U plus V over 2t if you want to. Or you can use good old-fashioned S equals UT plus half AT squared. Literally anyone works. And that's why it's another 3 marks. That's why I would argue that this is actually a 6-mark question straight away. Because once you've done part A, there's no way in hell you're getting part B wrong. Right? So it's effectively another 3 marks. yeah, and this part C is technically another type of question, which can be a little bit more tricky, but we'll see. It's not too bad. Anyways, so let's go and we can sub it all in. I'm not going to write out the values. I'm just going to type it straight in. U is 5, so we have 5, and T is 8, plus a half, which again is 0.5. A, which is what we worked out here, 1.88. T squared, which again is 8 squared. And that should be correct. I did remember the squared now. 100.16. We could leave that as 100 meters if we wanted to, and just say it's 3SF. Now for part C, this is where it gets a bit different. It says the time it takes for the car to reach the midpoint. Now, I would like to redraw the diagram just to make it a bit more clear. And there is a special reason for this. So let's call it A, let's call it B, and let's call the midpoint M. And this is where things are going to get a bit more interesting. And the reason why it's worth 4 marks is because there's a little bit more thinking we have to do. Unfortunately, I know. Now, we still know that the initial speed is 5. That hasn't changed. The acceleration is a constant, so it shouldn't ever change. It's 1.88. And in terms of the kind of time, we can't really say what the time is. But could we say what the speed is? Well, we know the speed over here is 20. Now, if I write out what we know for shizzle, S is going to just be 50 meters. Why? Because it's going for the midpoint. So that's 50 meters. U is equal to 5. V equals... I'm not going to say just yet. A equals 1.88. And time is also equal to... don't know. Now, because we have 3 things we want to work out a fourth, we can technically work this out as per usual. So all we need to do now is find an equation for S, U, A, and T, which is S is UT plus half AT squared. I'm going to show you a different method as well. And I think the reason why I want to do that is with these questions, there's so much variety that they can give you. I do recall a question where this trick that I'm going to show you a bit later actually came in very, very relevant. So anyways, doing this, we have 50 equals 5t plus a half 1.88 t squared. Now you might think, well, how on earth can I solve that? This is a quadratic. So move everything over to one side and I'll show you. So half of 1.88 would be 0.99. Not 0.99, sorry. But either way, you could do it on a calculator anyway. 0.94, that is exactly what I meant. 0.94 t squared plus 5t minus 50 equals 0. That is a quadratic. So all we need to do is solve it. And again, this is why I recommend this calculator. If you go to menu, you go down twice, to the right once, you have something that says equation/func. Press equals and go to polynomial. Degree is going to be 2 because we're looking at squares. If there was a cube, we would press 3. If there was a 4, which there shouldn't ever be, then you press 4. And we just type it in. So it says x squared here, but x is just a variable, we can call it t. So we can have 0.94 here equals, we have 5 here, and we have minus 50 over here. This gives me my 2 answers. So t is equal to 5.10 seconds, or t is equal to negative 10.42, 10.4, let's call it. So which one am I going to take? Because it can't be both, right? But remember, time can't be negative. So instead, I would put a box around this answer right here. And that's it for 4 marks. I think that's actually relatively light. But I hope you can see why I said that it's a bit different. Because we're expected to set up and solve a quadratic equation. Which, again, slightly trickier. Now, what was the other method I mentioned? And this is why I love mechanics. Because there's actually a shorter way of doing it where you can get the full 4 marks by kind of cheating. Now, because this acceleration is constant, at the midpoint here, the velocity at this point is halfway between 5 and 20. In other words, if you wanted to work this out, you just add them together. So 5 plus 20 equals... oh, God, sorry. Forgot that I didn't put it back into normal mode. Press number 1. 5 plus 20 equals, divide by 2, 12.5 meters per second. So what I could have done is just said that V is equal to 12.5 and then just used a normal equation. V equals U plus AT. Something like that. And I would get the same answer. Okay? And that's what I really like about this, because there are always easier ways of doing questions. Now this isn't particularly difficult, and this is the intended solution in the sense that that's why they give you 4 marks. But this is an entirely valid way of doing it as well. And it's a lot quicker. I have seen questions that give you 5 marks that someone has completed on 1 line and they get all 5 marks. In mechanics, the answer is just basically all they care about. And the reason for that is because there's so many different ways of doing it. And I just wanted to make you guys aware of that. So again, that works because we have a constant acceleration. Okay? In the same way that, let's say, I was walking between 2 points, and I walked at a constant speed. You would expect me to get halfway in half the time, right? Same thing here. You would expect me to get to midway at the middle of the 2 velocities in the exact same way, because it's constant. It's a straight line. The gradient is constant. I hope that makes sense. Just continuing from where we just left off. We have done 6 questions so far, and in the mark scheme and worksheet file I've included a further 6 questions which will test your kind of knowledge and understanding. Now you'll find in the mark schemes that they have been fully written through as well. So those extra 6 questions in the worksheet that you should absolutely try by yourselves now is, it's not optional, but you can do it. I won't go through them in the videos, but I will go through them as mark scheme answers. And if you guys have any questions at all, then I'll make further videos on those questions if needed. So again, this is kind of like a tuition lesson for you guys. It's an ultimate course, so if you do want anything or do request anything, just let me know and a video will be made on it. But I wanted to leave an extra 6 questions for you, and of course the mark scheme will be there if you need it with full written explanations, but just so you guys can do it in your own time and test your knowledge, okay? So we'll leave it there and we'll move on to the next part of mechanics, which is even more fun. But I want you to practice this before you go on to the next video, please and thank you. Have a great day, and I'll see you in the next one.